Hi there, my name is Pieter Bonte from Ghent University. And in this demonstrator I show you how you can create prototypes and applications that consume RDF streams in just a few simple clicks with Streaming MASSIF Prototypes. To do so, we will use one of the streams from the CityBench benchmark, a famous benchmark for RDF Stream Processing. Alright, let's get started. Alright, this is what the Streaming MASSIF Prototyping user interface looks like. First of all, there are various components available. Sources allow us to define the input of the data streams. We can add windows, we can add filters, define the logic based on SPARQL queries. We can add abstractors that allow us to add expressive reasoning, complex event processing, mapping functions to add the mapping from relational data to the semantic model, and of course sinks. And the whole platform is drag and drop. So first we define the input using a source. In this case we'll use a file source, we'll read one of the streams from file and we'll add a 1 second delay between the events. We'll also add a sink so we can easily investigate the content of the stream. We direct the output from the source to the sink by adding an arrow between them. In this case we will use a sink that just prints in the web interface in order to investigate the results. After activating the configuration, you can already see some metrics in the interface. You can see the number of inputs that has been received, the throughput, or the number of messages that are in the queue. So let's load what has been sent. So at this point we received a fragment of the stream, so we want to investigate what has actually been streamed. And this can be done in a table view where we see the various metrics that have been streamed to the platform. You can also visualize some of the metrics as a data stream itself. And here you can see a graph that is showing the input that we're receiving from the stream. So as can be seen, that the stream is not really an RDF stream yet, so first we add a mapping function that maps the raw data to the semantic model. And we just use the table names from the stream as variables in the mapping definition. Alright, so let's add another sink for debugging purposes so we can see the results of the mapping function. So now when we load the data from the sink, we can see that we receive semantic data instead of the relational data after the data has been mapped. So now we can add filter components, so we can filter out the relevant events in the stream using SPARQL queries. So first I added a select query that selects all the vehicle counts elements from the data stream, and using a select query you can also investigate it using the table view. So here we can see the results from each observations and the values that have been captured. So let's filter out the vehicle count events with a count above 10 instead of capturing all of them. So if we want to consume semantic data downstream, we should use a construct query instead of a select query to produce semantic data as well. So now that we have shown how we can filter out data using SPARQL queries, we can now define some more expressive reasoning components using the abstractors. That allows us to define higher level events using all class concepts. To do so, we will use the SSN ontology, where we have added 2 additional classes, a high vehicle concept observation and a very high vehicle concept observation. So now we can tell the platform that it needs to reason if there is such a high or very high observation in the stream present. So we add two abstractors, one for the high observations and one for the very high vehicle observations. So let's add another sink so we can observe the results after the reasoning components. So in the results you can see that the class definition has been added, that the event is in fact a high vehicle observation. So at this point we can detect temporal dependencies through semantic complex event processing. So let's detect when the traffic goes from high to very high within a limited amount of time. So the arrow operator defines a follow by in the temporal domain. Thus high traffic count followed by a very high traffic count. So let's add another sink to investigate the results. So after loading the results, we can see that the result is actually a complex event consisting of a high vehicle count and a very high vehicle count observation. So to conclude, in this demonstrator we have shown that with Streaming MASSIF Prototypes you can easily create prototyping for streaming RDF Stream Processing applications. If you have any questions, please drop me an email or ask me a question in discussion. And if you're also looking for contributors, so if you want to contribute, please visit our GitHub repository.